Hi everyone, this is Stefan. In this series of videos I will attempt to recreate the original set of XFL 5 tutorials made by Andre in the new software Flow 5 and go over its basic features. Flow 5 is the successor to XFL 5 and Sail 7 and has many more features than either of them originally did. Since these videos are meant as an introduction, I will not be able to go over every new feature in detail, but Andre has also written an extensive documentation and made a set of tutorials, which I highly encourage you to read and watch. I will also not cover the sail analysis, since I am not that familiar with the module myself, but many of the analysis steps are the same. Now, to start, we open the foil module. We can either create an airfoil ourselves or import an existing airfoil. Let's start with creating a NACA airfoil by going to Foil, Design, NACA Foils. Let's go with the NACA 2308 and 199 panels for now. Click Apply and Save. And we will go with the default name. As you can see, the airfoil appears in the Object Explorer on the left. Before starting an analysis, it is always a good idea to repanel to make sure the panel distribution is as smooth as possible, regardless if you created the airfoil in Flow 5 yourself or imported it. To do so, you can either right-click on the airfoil, refine globally, or you do it through the Foil, Active Foil menu. Generally, I like to use between 150 and 200 panels. We can also increase the panel bunching towards the leading and trailing edge with the slider at the bottom. In the future, it might be useful to look into bringing back a repaneling method based on curvature, since a good panel distribution at the leading edge is very important, but this method works for now. Just make sure the distribution is reasonably fine at the leading edge and in other important areas. Click Apply, Save, and we overwrite the old airfoil. To import an existing airfoil, click on the Load Foils button. Select the airfoil file and open. As you can see, the airfoil appears in the Object Explorer. The file needs to be in the CELIC format, which contains the tab-separated coordinates starting at the trailing edge, running towards the leading edge on the top side of the airfoil, and then wrapping back around to the trailing edge along the underside. If the airfoil does not load correctly, make sure it has the correct format, as other formats also use the .dat extension. After importing an airfoil from coordinates, you should always repanel, and it is also a good idea to make sure the airfoil is normalized. You can see this in the foil design view. Let's hide the NACA 4-digit airfoil for now. If the leading edge is not at 0 and the trailing edge not at 1, you should normalize the airfoil. You can do that by right-clicking on the airfoil, Modify, Derotate and Normalize, or you do it through the Foil Active Foil menu. Here you can use the option to normalize the airfoil. Since this airfoil was good, we don't need to make any changes and just click Don't Save. If we want to change the airfoil's and polars display color and style, we can do that through Style on the right side, or in the Object Explorer in any of the other views. To start an analysis, let's go back to the operating point view. We select the airfoil we want to analyze, go to Analysis, define an analysis. The available analysis types are the same as in Xfoil, type 1 to 3, as well as XFL 5's type 4 analysis, and also a new analysis, the type 6, which is used for flaps. I will cover this in a future video. For now, the most important one is type 1, which corresponds to a fixed Reynolds number and a varying angle of attack or lift coefficient. Let's go with a Reynolds number of 200,000 for now. And we will leave all the other parameters unchanged. On the right side, we can find the range of angles of attack or lift coefficients for which we want to run the analysis, minimum, maximum, and the step size. Sometimes it can be useful to start the analysis at 0 degrees to help Xfoil converge, in which case you can define multiple ranges starting at 0, but most of the time it should work fine without doing so. Click Calculate. Let's ignore the unconverged operating point for now. and we can see the pressure coefficient distribution for the selected operating point displayed in the plot. You can switch through the operating points with the Object Explorer. To view the entire polar, let's switch to the polar view. Double-clicking on a plot lets you change the variables, scales, and a bunch of other parameters. It also lets you add a second y-axis. To switch between plots, you can use the keys 1, 2, 3, 4, and 5 on your keyboard, or A for all, F for 4, or T for 2 plots. Now, to automate some of the work of generating polars for a plane analysis, we can run a batch analysis. As you can see, I have multiple options here. This is because I am running a pre-release version of Flow 5, so some of the things might look slightly different for you, but the functionality should be the same. The batch analysis lets you select multiple airfoils at once and run them for a range of Reynolds numbers and angles of attack. In the Polars tab, we can create a list of Reynolds numbers to analyze. When generating a polar mesh, a sort of exponential distribution is useful, as the differences in results are usually greater at lower Reynolds numbers. You can change the range of angles of attack in the operating points. Here you have the same list available as before. Click Calculate and it will run the analysis for all the selected airfoils and Reynolds numbers.